Welcome to the video lessons for Math 1130, College Algebra. We're going to start off with exponent rules. And in this video, we'll look at exponent rules for multiplying. First of all, let's understand what exponents mean. Exponents represent repeated multiplication. So if I saw -6 in parentheses raised to the third power, that would be -6 multiplied by itself 3 times, or -6 times -6 times -6. Now you can put it into your calculator in the exponential form, or you can multiply it out as I've written here, -6 times -6 times -6. Either way should come up with the same answer. I'm going to show you using an online calculator called Desmos, and you are allowed to use this when you're testing. The URL is desmos.com/practice. That's the URL that you can use on your tests. Now they have a scientific calculator and they have a graphing calculator. For just putting in numbers or expressions, you'll want to select the scientific calculator and then click on Start Practice. So I want to go ahead and put in -6 to the third power. So I put parentheses. I use the negative key or subtraction key, and then the number 6, close the parentheses. To do an exponent, I'll use this A to the B key. And then I'll put the third power right there, hit the blue arrow button, and my answer comes out as -216. Now notice it would be the same answer if I put parentheses -6, close the parentheses, do another set of parentheses with another -6, and then a third set with a -6. So -6 times -6 times -6. So you can use the exponent key or write out the entire multiplication. All right, so that comes out as -216. Now I have -8 squared, which would be the same as -8 times -8. Now I know 8 times 8 is 64, and a negative times a negative gives me a positive, so this would actually come out as a positive 64. Notice that when I had an odd exponent, and I had a negative raised to that odd exponent, the result was negative. But when I had a negative raised to an even exponent, the result was positive. And that comes from the fact that a negative times a negative equals a positive, but a negative times a positive is equal to a negative. So when I was doing -6 times -6, the negative times negative came out as a positive, and then I multiplied again by a negative, so I had a positive times a negative, and that's why the result came out negative. Whereas when I had an even exponent, I got a pair of negatives, so negative times negative, which gave me a positive. All right, now that we understand exponents and what they mean, let's look at the multiplication rules for exponents. So the first one is called the product rule, and it tells us that when multiplying exponential expressions with the same base, we add the exponents. And we use this sum as the exponent of the common base. Now the base is the part that's being raised to an exponent. So let me write down here, if I had a b and then an n in the superscript is the exponent. And the regular size script is called the base. So if I have b to the m power times b to the n power, that would be b to the m plus n power. So for example, if I had 2 squared times 2 to the third, that would equal 2 to the 2 plus 3, which would give me 2 to the 5th power. And you could also figure that out by using the definition of exponent. 2 squared is 2 times 2. And 2 to the third is 2 times 2 times 2, so 3 times. And then you count up how many 2's you have. You have 5 of them, so that's the same as 2 to the 5th. So this is really a shortcut way of getting that new exponent without having to write it all out like this. Now that only happens if you have the same base and you're multiplying them together. The next one is called the power rule, and it tells us that when an exponential expression is raised to a power, you multiply the exponents and remove the parentheses. So for example, let's say I had 5 to the 4th power raised to the 3rd power. Notice I only have a single base here, and then I have the 2 powers written next to each other. So I would multiply 4 times 3, and that would give me 5 to the 12th power. That would be my solution. Now you could figure that out by using the definition of exponents. So 5 to the 4th raised to the 3rd power would be 5 to the 4th times 5 to the 4th times 5 to the 4th, 3 times because it's to the 3rd power. And then I could use the rule that I showed you above, the product rule, and that would be 5 to the 4 plus 4 plus 4, which would give me 5 to the 12th power. So you can do it the long way, or you can use these exponent rules, which will shorten your amount of work. The last one is products to powers. When a product is raised to a power, raise each factor to the power. So if I have a times b in parentheses raised to the nth power, that's equal to a to the n times b to the n. So for example, say I had -2 times x, I'm going to use x instead of another number, raised to the 5th power, that would equal -2 raised to the 5th power times x raised to the 5th power. So that goes, the power goes to both parts of the product. So that only works if these two things are being multiplied in the parentheses. And then you could go ahead and actually figure out the numeric part. If you pull up your calculator, you would put parentheses, -2, close the parentheses, use that exponent key, and raise to the 5th power. So we would end up with -32 x to the 5th. So this is equal to -32 x to the 5th. Now we can use these rules together. Like, for example, if I had something like, let's say I had 3 times x squared raised to the 4th power, I could start by using this powers to products rule, and that would be written as 3 to the 4th times x squared to the 4th. Then I would have to use the power rule that says that I would multiply the 2 and the 4 to be the new exponent on x. So I would get x to the 8th power, and I would want to go ahead and figure out 3 to the 4th power. So in my calculator, I would put 3, use the exponent key, and do the 4th power. So we get 81 x to the 8th. So sometimes the rules are used together to do some more complex expressions. In the next video, we'll continue with different rules of exponents.